Hey everyone, welcome back to my classes. So today we'll do kinematics. Now kinematics is all about the different kinds of motion we have to know. So in kinematics, you have to know uniform motion. You also have to know harmonic motion, and you also have to know circular motion. Now, I've done circular motion in my earlier classes, so you can go watch that video. But today I'll focus on harmonic and uniform accelerating motion. Yeah. So let's start with the very basic stuff. So in kinematics, you have two types of distance. You have the distance, right? The distance is the length that is covered between 2 points. So if you have 2 points, it can be any 2 points. So let's say this distance is this path is my distance. Now I can also travel like this as well, and this can be my distance as well. And similarly, I can go from here to here. I can go from here to here like this. La la la. Yeah. Point is, any length covered between 2 points is called my distance. So, what is displacement then? Displacement is the shortest length between 2 points, which is a straight line. So, for example, in this case, when I have these 2 points, the distance covered, that is the shortest length. So for example, this line right here, it's a straight line and it's the shortest path that I can take between my 2 points. So this is my displacement. Similarly, if I have 2 points and I go like this can be my displacement as well, and this right here, this right here is my distance. Why is that? Because distance is any length, whereas displacement is the shortest length. So the straight line right here. Now remember that they can confuse you and say that, hey, this is a straight line. Is this a straight line as well? This is a straight line as well. Any line can be called a straight line if it's not a circle. Remember that. Moving on, remember that the differences between vector and scalar. So scalar quantities, remember, will only have amplitude, whereas my vector quantities will have displacement or direction. Direction. So in displacement, remember, displacement is a vector quantity, distance is a scalar quantity. So displacement will have both direction as well as my amplitude. Amplitude is a fancy word for a value. So for example, distance can be 12 meters. Displacement can be 12 meters towards the right. So you have to point the direction in which your displacement is in. So moving on with speed. Speed, remember, is the rate of change of distance. So the formula for speed, S, is my distance over time. Remember this. So rate of change of displacement, rate basically means a change in something. So velocity is the rate of change of displacement, and velocity is vector. Speed is scalar. So I have to point my direction in velocity as well. For example, I can say my speed is 12 meters per second, but in velocity I have to state 12 meters per second as well as my direction. So direction towards the right, towards the left, any type of direction. Now acceleration is the rate of change of velocity, and remember, acceleration is also vector. Acceleration formula is v minus u over t, where v is the final velocity, so the final speed or velocity, whereas u is the initial velocity, the speed or velocity that you started with. And yeah, deceleration is negative acceleration or negative acceleration. So what is deceleration? Remember that acceleration, I told you, is a vector. That basically means that acceleration has a direction. So it can go right, it can go left, it can go up and down. So if I take my right as positive, then my acceleration in the right direction would be positive. But if I'm moving my car, for example, I have a car that is going in the left direction. Now, in the left direction, I have to say that my acceleration is going to be negative. So, negative acceleration is deceleration. So basically, I can apply the same method in this case. So if I'm going up, then my acceleration is positive. If I'm going down, my acceleration is negative. So remember that um, all the directions must have signs. Usually the right side is positive and the left side is negative, and the up side is positive, the downside is negative. Yeah. And yeah, so let's move on with graphs. Graphs are very important. So for now, you only need to know the distance, the speed, and the acceleration graphs. Remember that in a distance time graph, the gradient, the gradient is your speed or velocity, your speed. In the case of distance, it's going to be speed. In the case of displacement, it's going to be velocity. All right. So why is that? You also have to know how to prove this. Remember that in a distance time graph, the gradient would be rise over run. Run. Yeah. And rise is when you're going up. Rise is when you're going up, so that would be distance. And run would be when you're going in the x direction, that would be time. So this is the formula for speed or velocity. All right. So this is how you calculate the gradient. And using that gradient, you can figure out the speed of your object. So in the case of my distance time graph, moving like this straight line, my gradient is constant. Since my gradient is constant, my speed would therefore be constant. In this case, when I'm going like this, in this case, my gradient is increasing. You can see that this line at the very bottom is a slope, but as you go up, you're moving, the line is becoming straight. So the more straight the line becomes, the more steeper the gradient becomes. And when the gradient is steeper, you're saying the speed is also steeper, or the speed is increasing. Remember, when you have this type of graph, that means your gradient is increasing. So but when you have this type of graph, this means your gradient is constant. When you have a decreasing graph, what do you mean by decreasing? Decreasing is like this. When your gradient is decreasing, it's going to look something like this. And when it's like this, your gradient is decreasing. And remember, in a distance time graph, the gradient is speed, so your speed is also decreasing. All right. This is a question you can do. You have to state the speed at each time. So from going from A to B, what's your speed? Going from B to C, what's your speed? C to D, what's your speed? You can look at this. I'm not going to waste my time here. Yeah. So projectile motion. Let's move on to projectile motion now. In projectile motion, you have three main formulas. So S equals ut plus half at square. Why am I writing the formulas? It's already written here. Yeah, let me zoom in. Yeah, this is better. So in my projectile motion, you have to know these formulas, and this states S equals ut plus half at square, where S will be my displacement. My V is my final speed. V is my final velocity, or final velocity, not speed. U is my initial speed, initial velocity. And A is my acceleration. Pretty simple, right? Yeah. And finally, T is obviously my time. So these equations can only be used when your acceleration is constant. That means in all of these formulas, the acceleration that you're going to use must be equal to the acceleration due to gravity. The acceleration due to gravity is 9.81. Usually you'll use 10 meters per second square in your exam. Yeah, both works. If acceleration is zero, if my acceleration is zero, that basically means that I'm not increasing my speed. Because if acceleration is constant, then if I have a car that is accelerating constantly, that my speed, v velocity, will increase at a constant rate. But when someone says my acceleration is zero, that basically means that the car is not accelerating and the velocity is therefore not increasing or decreasing. It's constant. So remember that if acceleration is zero, that basically means constant speed. So when I have constant speed, when someone says my acceleration is zero, then I will use my simplest formula, which is distance is velocity times time. You can figure the velocity, you can find velocity from this formula. Yeah. So yeah, and let me just erase this. Yeah, and remember that velocity decreases at a constant rate as the object moves up and increases at a constant rate as the object moves down. What is this phenomenon? So let me explain it in a simple way. So let's say I have a ball. I throw this ball in the sky. This ball will go up, and somewhere at a height, it will reach some height, and then it will start to go down. Now, if you've noticed, if you have a brain, then you realize that the ball is not going up. It's not moving up like rockets do. So it will eventually, at some height, it will reach some height, then it will stop, and then it will change direction and move down. So remember that in this case, why is my ball not going up? Why is it going down? Because remember that your gravitational force or acceleration, which is 9.81, remember that this acceleration is in the downward direction. So 9.81 is in the downward direction. So your ball will always have some kind of force or acceleration downwards, because the earth, this is the earth, it's pulling this ball towards itself. So yeah, because of this, your gravitational force would be always negative 9.81. Because remember, when the ball is going up, the my gravity is always pulling it down. So this is one thing. The second thing is that at when you're moving up, right? When you're moving up, your velocity is decreasing. Why is that? Because when you're moving up, there is a force that is pulling you downwards. So let me explain it in a simple way. Let's say you have a car. This car is attached to a spring or a rope, and it's trying to move this way, but the rope is pulling it backwards. So in this case, in the case of my ball, the rope that is pulling it backwards is my gravitational force or gravitational acceleration. Now, because of this, as your ball is moving upwards, as the ball moves towards the sky, remember that your velocity will decrease. This is because of many things. First, there is always gravitational force. That's one thing. The gravitational force or gravitational acceleration is always pulling you down. The second thing is air resistance. Air resistance is basically the air particles in the sky, in the air, because you're constantly colliding, this ball is constantly colliding with air particles, and because of this your speed would decrease. Now this is one thing. The second thing is that when your ball reaches the height where it will change its direction, so initially the ball was moving up, but it reaches a certain distance, it reaches a certain height from the base, from the place where you threw this ball. So let's say Talal threw this ball up. So the distance from the point he threw the ball is your height. And remember that in this formula, the displacement S is going to be your direction from the base to the height. All right, if it's going up. But if it's going down, this is when you'll only consider from one point to another point. You'll consider it as S if your ball is only going up. But if it goes up and it comes down, it reaches some height and then it comes down back to its position. So in this case, you'll not say it's S. Your distance or displacement is not S, but instead it's 2S. Why is that? Because first you traveled one place. You traveled one distance in the upward direction and then you moved back towards your original position. So this case, you've traveled twice the distance, so you'll consider it as 2S. Now, that's the second thing, and the most important rule of all of uniform motion is that at a certain height, your ball will stop. Why will it stop? Because it wants to change direction. So when it stops, at this point, your velocity or your speed would be 0. Remember that. Your speed would be 0 at some point. All right, so that's one thing. At a certain height, the point where the ball reaches the maximum height, it will the velocity will become 0. So remember, at maximum height, your velocity is 0. Yeah. And when this happens, your ball will change direction. So at maximum height, your ball changes direction and moves downwards. All right. And this was when your ball is traveling in air. Now, another phenomenon or another type of question you'll find is when your ball is moving in the slope. So if your ball moves in a slope, it's the same thing. When your ball is moving up, the velocity would decrease. But when your ball is moving down the slope, your velocity would increase. This is very common. All of you guys know this. Your velocity increases when you're going down. Your acceleration is constant here. Now, there is a problem that in these types of questions, you will consider air resistance. So there are two types of resistances that you can find. So one is air resistance. The second is friction. Friction. Yeah, I'm not writing that. Ignore. Friction is when whenever you have some object moving in on a surface, your speed would decrease because friction will act on that ball. So friction, remember, it always acts in the opposite direction towards your motion. So if your ball is moving up, then your friction will be towards the left. And remember, friction is a force and forces are vector quantities. So friction acts in the opposite direction toward to your motion. So in the case of your ball moving downwards, friction will act in this way. This is your friction. Yeah. And so there are some rules that you have to know for projectile or uniform motion. It's that vertical acceleration is always 9.81. In the case when you are using these three formulas right here, the acceleration A that you'll write is going to be 9.81. All right, 81. Yeah. So yeah, and also remember that horizontal velocity is always constant. Therefore, horizontal acceleration is 0. What does this mean? In the case of horizontal velocity, so when your ball is moving, let's say in this direction, so you threw your ball, this time you didn't throw your ball straight up. In this case, now you threw your ball like this, so that it reaches somewhere right here at the same ground height. So in this case, whenever I'm throwing my ball in a certain direction instead of it throwing upwards, then remember that your velocity will have two components: the horizontal component of your velocity and your vertical component of your velocity. Now, in the vertical, or in the vertical case, when your velocity is like this, then in this case your velocity would not be zero. Your velocity would not be zero. It would increase or decrease because of gravitational, because remember, gravitation acts vertically, gravitational force acts vertically. But in the case of horizontal velocity, always remember that horizontal velocity is always constant. Why is that? Because in all of the questions that you'll find, they will say that air resistance is negligible. When they say air resistance is negligible, that means there are no molecules in the air. We assume this. Obviously, this is not true. If this was true, then we'd not be breathing right now. But yeah, anyways, air resistance is negligible. So in the case when my ball has horizontal velocity, meaning in this case left or right, then my velocity would be constant. All right. When it's constant, my horizontal velocity would always be constant, and so I will always consider my vertical accelerations, not my horizontal acceleration, because other than air resistance, there is no other forces acting on the ball horizontally. All right, so yeah, this is one thing. The second thing is, when velocity is constant, you'll use distance equals velocity times time. I've explained this. Yeah. So, yeah, let's move towards simple harmonic motions. Simple harmonic motions. What is simple harmonic motion? Remember, simple harmonic motion is periodic motion in which acceleration is directly proportional to displacement and is always directed towards the mean position. So remember, acceleration is directly proportional to the displacement x, and this displacement is always negative. So where does simple harmonic motion apply? It applies to any type of motion that is repeating itself. So a ball attached to a hinge that is moving like this, so it goes like this and then comes back and then keeps repeating itself. And the second type of simple harmonic motion is a spring that stretches, goes back up, comes down, yeah, repeats itself. So these are the two main types that you will find in your questions. Now, the only thing that you need to know is this formula right here, that acceleration is equal to my negative omega square into my displacement. This is one formula that you need to know. And the other thing that you need to know is what is happening to your velocity. So first of all, when you have this ball right here, when it goes towards the right, always remember, when it reaches its maximum position at the right or at the left. So if it's at the maximum right, then at this point your velocity is zero, because like a ball being thrown up, like the case when I told you right here, where is it? Yeah, this scenario, when the ball reaches its maximum height, your velocity will reach zero. Similar case is right here. Where is it? Yeah, right here. When you reach your maximum height in a ball with attached to a rope, in this case your velocity would be zero. This is at maximum height. When you're at the very left as well, your velocity is zero as well, because this place is your maximum height. You cannot go any further. So maximum height's velocity is zero. when is velocity maximum? Velocity is maximum at the equilibrium position or at the very center. So when it's at the center, remember that your velocity would be maximum. So maximum velocity is at the center or the equilibrium, but velocity is zero at the maximum height or maximum positions. So the ball is initially at the equilibrium, so it starts to move towards the right. At this point, your velocity would start to decrease. It reaches a certain height. So for example, it reaches a maximum height. At this point, your velocity would be zero. And then it changes direction. And when it changes direction, its velocity starts to increase. So when it changes direction, its velocity starts to increase. It reaches the mean position again, and then it goes towards the very left. So like this, and then when it's going towards the left, its velocity is decreasing. Now at a certain height at the very left, its velocity would reach zero, and then it would change direction and move back towards the mean position. At this point, at the very mean, as it moving towards the mean position, your velocity would keep increasing. All right. So I can draw a graph. Let me just erase this and explain it in a graph. So remember that they'll give you a graph like this. They'll give you this horizontal line. This is your equilibrium position. This is when the ball is at this point. So the journey starts, and you can see that the distance, this is by the way a distance time graph. The distance is increasing. The distance, remember, is increasing, and the distance is always calculated from the mean position to the maximum height. So for example, the ball reaches this maximum height. It will not go any further. So this is your maximum distance d. Now so as the ball moves towards the right, as the distance right here, as the distance increases, my velocity is decreasing, and then it reaches the maximum height. It reaches this maximum height. Velocity right here at maximum height is zero, and then it changes direction. And then it goes back to the mean position. So this is when it's moving back, and right here my velocity is increasing. So at this point my velocity is increasing, and it reaches the equilibrium. And then it changes direction. So now it's going towards the left. It reaches the maximum position at the left. At this point my velocity is maximum, and then it changes direction, goes back, and then yeah, you'll do like this. You get the point, right? So this is simple harmonic motion. Now other than that, you also have to know what is happening to my kinetic energy and my potential energy. So this was the case when I was explaining with balls. Now this will be the same case when you have a spring. So when the spring is going down, it will reach a maximum height, then it will go back, reach its equilibrium position, and then it will go towards the top, and then it would repeat. And in that case, this will be the same case. So when it's at the very bottom, my velocity would be zero. When it's at the very top, my velocity would be maximum, and at the center my velocity would be my velocity at the very top would be zero as well. The velocity at the center would be maximum. Yeah. So the final thing you need to know is what happens to my potential energy and what happens to my kinetic energy. All right. So when my ball is at the equilibrium, my velocity, I told you, is maximum. And kinetic energy is half times half into mv square. This is the formula for kinetic energy. So when my velocity is maximum, when is it maximum? It's maximum at the equilibrium, when it's at the center. So when the ball or the spring is at its center, my kinetic energy would be maximum. But when my ball or my spring is at its maximum height, so for example here or here, in these 2 points, my kinetic energy would be 0 because my velocity, I told you, at the maximums are 0. Velocity right here is 0 as well. Alright, so yeah, kinetic energy is maximum at the center but 0 at the maximum heights. At the very left and right, my kinetic energy would be 0. This is the same case in the spring scenario. When the spring is at its very top, velocity is, I told you, it's 0. So my kinetic energy would be 0 as well. So what happens to my potential energy? Potential energy depends on distance, because the formula for potential energy is mgh. Now, so potential energy is depending on my height. Remember that. So these two, mass m is constant, the ball's mass would not change, and g is 9.81. This is also a constant. So what will change is my height. So at the very maximum positions, at the very left and at the very right, my distance from the equilibrium is maximum. This is maximum. So at maximum displacement, so at the very right and at the very left, my potential energy is maximum at the left and very right. So but at the equilibrium position, my distance is 0. Remember that your distance will always be calculated, the distance or height will always be calculated from the mean position. So distance at the very mean position is 0. So mgh, where h is 0, so my potential energy would be 0. When I move to the very left, the distance is maximum, so my potential energy would be the greatest as well. And it's the same case when I'm dealing with springs. So in springs, when I'm at the very top from the mean position, my mgh is maximum, so my potential energy therefore is maximum as well. But when I reach the mean position, this is not a spring. When I'm reaching this mean position at the center, the potential energy, remember, it's 0. Remember that, 0. But when I'm at the very bottom, so when I'm at the very bottom, my distance is the greatest from the mean position. This distance is the greatest, therefore h is greatest and potential energy is maximum. So yeah, and I think that's pretty much it. Yeah, the last thing, the simplest thing is damping. There are 3 types of damping: light damping, heavy damping, and critical damping. Damping is when there is a loss of amplitude due to energy loss overcoming friction. Amplitude is basically my maximum distance. So there are 3 types. Critical is when the system returns to equilibrium position in the shortest time possible without any oscillation. For example, in critical damping, when I have this ball attached to this rope, it will go back to its equilibrium position the fastest. In heavy damping, the system returns to equilibrium position very slowly without any oscillation, and in light damping, the amplitude decreases gradually. So a good way to explain this is through graphs, displacement time graphs. In light damping, my oscillation will continue, but it would decrease. So my maximum amplitude decreases every oscillation. So what do I mean by this? In first oscillation, this is one oscillation. So when the ball moves right, left, and it comes back, this is one oscillation. The next oscillation would be much less. So for example, like this, and then like this. So in this case, my amplitude or the maximum height decreased. This is light damping. In heavy damping, something looks like this, and in critical damping, it looks like this. And friction force in heavy and damping is more compared to critical damping. Yeah, that is pretty much the syllabus for IMAT. There is resonance, but yeah, you don't need to know this. This is for A levels. This is big boy stuff. Yeah. This was pretty much it for today. And yeah, see you tomorrow. Bye.